Before the roar of diesel engines and the hum of hydraulic systems, before GPS guidance and climate-controlled cabs, there were machines that changed everything, crude, mechanical marvels that replaced horses and transformed agriculture forever. Today, we're counting down 9 tractors that are over 100 years old. Machines built when internal combustion was revolutionary, when 20 horsepower seemed like magic, and when farmers took enormous risks betting their livelihoods on unproven technology. These aren't museum pieces gathering dust. These are the pioneers that proved mechanized farming could work, that established brands still trusted today, and that created the foundation for every tractor built since. From Hungarian experiments that barely survived, to mass-produced American machines that changed the world, from single-cylinder curiosities to innovative designs that solved problems engineers didn't know existed, these tractors represent humanity's first steps toward modern agriculture. Some failed, others succeeded beyond imagination, but every one of them mattered, and their stories deserve to be told. Number 9. Allis-Chalmers Model 1018. In 1918, when the Great War was ending and American agriculture was desperate for mechanization, Allis-Chalmers entered the tractor business with the Model 1018. This wasn't the company's first attempt at building tractors. They'd experimented with earlier designs, but the 10-18 represented Allis-Chalmers' serious commitment to agricultural equipment. The 2-cylinder gasoline engine produced between 10 and 18 horsepower, depending on load, modest power, but adequate for the small to medium farms that dominated American agriculture. The design was compact and relatively lightweight compared to behemoth steam engines farmers were replacing, weighing around 3,600 pounds, ready to work. Allis-Chalmers built the 10-18 for practical farming rather than impressive specifications. It pulled single-bottom plows through Midwestern soil, powered threshing machines during harvest, and handled belt work that previously required steam engines or horse teams. The 2-cylinder engine was simple and reliable, using technology farmers and local mechanics could understand and repair with basic tools. The exposed design, with no hood or cosmetic covers, meant every component was visible and accessible. Philosophical approach to farm equipment that prioritized maintainability over aesthetics. The 10-18 featured friction drive transmission that provided variable speed without gears. Innovative but temperamental system that worked well when properly maintained but failed when neglected. The steering was rudimentary, a simple chain and sprocket system that required physical strength and anticipation because there was no power assist and minimal mechanical advantage. The fuel tank held approximately 16 gallons, enough for a full day's work but requiring constant monitoring because running dry meant tedious bleeding and restarting procedures. The 10-18's greatest contribution wasn't technical innovation, but market validation. It proved that established manufacturers could successfully enter the tractor business, that farmers would trust new brands if the machines performed reliably, and that the tractor market could support multiple competitors. Allis-Chalmers would go on to become one of America's major tractor manufacturers, building iconic models through the 1960s and 70s. But it started with the humble 10-18. Production numbers were modest, a few thousand units over several years, but the impact exceeded the numbers. Today, surviving 10-18-year-olds are rare and valuable to collectors who appreciate Allis-Chalmers' history and the machine's role in establishing a brand that would compete with Deere, International Harvester, and Case for decades. Number 8. John Deere Waterloo Boy. John Deere's entry into tractor manufacturing came not through internal development, but through acquisition. In 1918, Deere purchased the Waterloo Gasoline Engine Company, manufacturer of the Waterloo Boy tractor that had been in production since 1914. The acquisition gave Deere instant credibility in the tractor market and a proven design that required only refinement rather than complete redesign. The purchase price was approximately $2,300,000, an enormous investment that reflected Deere's recognition that tractors were the future of agriculture and that entering the market late risked losing their dominant position in farm equipment. The Waterloo Boy featured a horizontal 2-cylinder gasoline engine, producing approximately 25 horsepower, positioned lengthwise in the frame with massive exposed flywheels that dominated the tractor's profile. The 2-cylinder design created Waterloo Boy's distinctive exhaust sound, a slow, methodical beat that would become John Deere's signature for the next 4 decades. The engine displaced 465 cubic inches, enormous by modern standards, but necessary given the low compression ratios and inefficient combustion of early engines. The cooling system used thermosiphon circulation. No water pump, just natural convection moving coolant between engine and radiator. Simple but effective, as long as the radiator remained clean and full. The transmission provided 2 forward speeds, typically around 2.5 miles per hour in low gear and 3 miles per hour in high, plus reverse. These speeds sound absurdly slow by modern standards, but they match the pace of horse-drawn implements and gave operators time to react to obstacles or changing conditions. The Waterloo Boy weighed approximately 6,200 pounds, substantial mass that provided traction and stability but made transport between fields challenging. The large steel wheels with cleats provided excellent traction in soft soil but made road travel jarring and slow, with speeds rarely exceeding 4 miles per hour on hard surfaces. The chassis design placed the engine low and forward, creating decent weight distribution but making some maintenance tasks difficult because components were tightly packaged. The fuel consumption was prodigious by modern standards. The Waterloo Boy could burn through 16 gallons during a full day's work, but kerosene fuel was cheap and the power output justified the consumption. The Waterloo Boy could operate on kerosene after starting on gasoline, a common feature of the era that allowed farmers to use less expensive fuel for the bulk of their work. The Waterloo Boy's greatest significance wasn't its technical specifications, but its role establishing John Deere in the tractor business. Deere was already famous for plows and other implements, but tractors were different. Complex machines requiring engineering expertise and manufacturing capabilities Deere was still developing. The Waterloo Boy gave Deere time to learn the tractor business, while offering farmers a proven product bearing the trusted John Deere name. Production continued through 1924 when Deere introduced the Model D, their first wholly designed tractor. But the Waterloo Boy's influence persisted in the 2-cylinder design philosophy that defined Deere tractors until 1960. The Model N and Model R versions of the Waterloo Boy sold in substantial numbers, with production totaling over 20,000 units during the tractor's production run under Deere ownership. The Waterloo Gasoline Engine Company's factory became John Deere's tractor manufacturing center, and the Waterloo, Iowa facility would build Deere tractors for the next century. Today, Waterloo Boys are highly collectible and frequently featured at vintage tractor shows, valued both for their connection to John Deere history and for their mechanical simplicity that makes restoration feasible for dedicated enthusiasts. The distinctive sound of a running Waterloo Boy, that slow 2-cylinder beat, evokes nostalgia for collectors who remember when that sound was common across American farmland before 6-cylinder diesels and modern engines made the Johnny Popper sound a memory. Number 7. Fordson Model F. Henry Ford revolutionized automobiles with mass production and the Model T. In 1917, he applied the same principles to tractors with the Fordson Model F, and the results changed agriculture forever. Ford's goal was audacious: build a tractor so affordable and reliable that every farmer could own one, replacing horses entirely and transforming agricultural productivity. The Fordson featured a 4-cylinder gasoline engine producing approximately 20 horsepower, modest compared to larger tractors, but perfectly adequate for the small to medium farms that comprise the majority of American agriculture. The engine displaced 251 cubic inches and used Ford's proven automotive technology adapted for agricultural applications. The revolutionary aspect wasn't the engine, but the integrated design. Ford used the engine block, transmission case, and rear axle housing as stressed members of the chassis, eliminating the separate frame that other tractors used. This unit construction reduced parts count, simplified assembly, and lowered manufacturing costs dramatically. The Fordson initially sold for approximately $750, roughly half the price of comparable tractors, and within reach of farmers who'd never considered mechanization affordable. Ford's mass production techniques, moving assembly lines, interchangeable parts, vertical integration, drove costs down further as production ramped up. By the early 1920s, Fordson prices dropped below $400 as Ford engaged in price wars with competitors, particularly International Harvester. The low price had consequences. The Fordson was basic, utilitarian, and lacked features that more expensive tractors offered. There was no power takeoff initially, limiting implement options. The transmission provided 3 forward speeds, but the ratios weren't well suited to all farming applications. The steering was heavy and required significant effort, and the rear wheels were too close together for some row crop applications. More seriously, the Fordson had dangerous tendencies to flip backwards if the plow hit an obstruction, killing dozens of operators before Ford modified the design. But despite its flaws, the Fordson succeeded beyond Ford's ambitious goals. Production exceeded 750,000 units by the time American production ended in 1928, making it the first truly mass-produced tractor and establishing mechanization as feasible for ordinary farmers rather than just wealthy operators. The Fordson was exported worldwide, introducing mechanized farming to regions that had never seen tractors. In Britain, where production continued after American manufacture ceased, Fordsons became the dominant agricultural tractor for decades. In Russia, Fordsons were copied and produced as the first Soviet tractors, industrializing agriculture across vast territories. The Fordson's cultural impact exceeded its technical sophistication. It proved that tractors could be affordable, that mass production principles applied to agricultural equipment, and that one manufacturer could dominate through price and availability, rather than superior technology. Today, surviving Fordsons are common at vintage shows because so many were built, but they're treasured for their historical significance and for representing the moment when tractors shifted from expensive luxuries to essential tools accessible to ordinary farmers. Number 6. Case 12 to 20. The J.I. Case Threshing Machine Company had built steam engines for decades when it entered the gasoline tractor market in 1911. The Case 1220, introduced in 1912, represented Case's effort to create a modern, reliable gasoline tractor that could compete with emerging competitors while leveraging Case's reputation for quality and durability. The name indicated the tractor's capabilities: 12 horsepower at the drawbar for pulling implements, 20 horsepower at the belt pulley for stationary work like threshing or sawmilling. These ratings reflected realistic working power rather than maximum output, a conservative approach that built trust with farmers, who'd been disappointed by competitors' inflated claims. The 12 to 20 featured a 4-cylinder gasoline engine displacing approximately 461 cubic inches, large displacement that provided adequate torque at the low engine speeds typical of the era. The 4-cylinder design was more refined than the 2-cylinder engines many competitors used, running smoother and producing more consistent power. The engine used atmospheric intake valves, spring-loaded valves opened by intake suction rather than camshaft-operated valves. Simple system that was reliable but limited engine breathing and power. The cooling system used an automotive-style radiator with thermosiphon circulation, effective in most conditions, though inadequate in extremely hot weather or when working the engine hard for extended periods. The transmission provided 2 forward speeds, approximately 2 and 3 miles per hour, and reverse. The final drive used enclosed gears running in oil, sophisticated feature that reduced wear and maintenance compared to the open chain drives some competitors used. The 12 to 20's chassis was substantial. The tractor weighed approximately 5,500 pounds, providing stability and traction, but making transport between fields time-consuming. The large drive wheels, over 50 inches in diameter, provided excellent ground clearance and allowed the tractor to work in muddy conditions that would bog down smaller-wheeled machines. Case equipped the 12 to 20 with a substantial platform for the operator. Though calling it a seat was generous, it was a basic perch that provided positioning but minimal comfort. The controls were simple and mechanical: a hand throttle controlled engine speed, a lever-selected transmission gear, and a large steering wheel connected through chains to the front axle. The 12 to 20 burned approximately 1 gallon of gasoline per hour at working load, fuel consumption that was reasonable for the era and compared favorably to the kerosene engines some competitors offered. Case built the 12 to 20 through 1916, producing several thousand units that worked farms across America and were exported to Canada, South America, and other markets where Case dealers operated. The 12 to 20's significance lies in establishing Case as a serious tractor manufacturer and proving that quality and reliability could compete with price-focused competitors. Case would go on to become one of America's premier tractor manufacturers, building legendary machines through the 20th century. But the 12 to 20 was where it started. Today, surviving 12 to 20-year-olds are treasured by Case collectors and regularly appear at vintage shows, valued for their role in Case history and for their mechanical simplicity that makes restoration and operation feasible for enthusiasts with modest budgets and basic machining skills. Number 5. Rumely Oil Pull. The Advanced Rumely Company's oil pull tractor introduced in 1910, represented one of the most innovative and successful early tractor designs, using oil cooling rather than water and running on inexpensive kerosene fuel. The oil pull name came from the oil cooling system. The engine was cooled by circulating oil through passages in the cylinder head and block, then through a large radiator where airflow dissipated the heat. This system eliminated the freezing problems that plagued water-cooled tractors in northern climates, where frozen cooling systems could crack engine blocks and disable tractors during critical fall and spring work periods. The oil cooling also allowed the engine to run hotter than water-cooled designs, improving thermal efficiency and allowing the engine to burn low-grade kerosene fuel that was significantly cheaper than gasoline. The engine design was massive and robust. Early oil pull models used 2 horizontal cylinders, displacing over 1,000 cubic inches combined. Enormous displacement that produced between 20 and 40 horsepower, depending on the model. The engine speed was extremely low, typically 300 to 400 revolutions per minute, creating tremendous torque and a distinctive slow exhaust speed. The massive flywheels, often 6 feet in diameter and weighing hundreds of pounds, stored energy and smoothed power delivery despite the 2-cylinder configuration. The chassis was equally substantial. Oil pull tractors weighed between 10,000 and 20,000 pounds depending on model, providing excellent traction and stability, but requiring substantial timber bridges or reinforcement when crossing wooden structures. The transmission was rudimentary, typically offering 2 forward speeds, both extremely slow by modern standards, but adequate for the belt work and plowing that comprised the tractor's primary applications. The oil pull's cooling system required significant maintenance. The oil needed regular changing and filtering to remove combustion contaminants. The radiator needed cleaning to maintain heat transfer, and the system needed monitoring to prevent overheating that could break down the oil and damage the engine. But farmers who maintained their oil pulls properly reported impressive reliability and longevity. Many oil pulls worked for decades, accumulating work hours that would destroy lesser machines. The fuel economy was excellent by early tractor standards. The oil pull could run all day on 20 to 30 gallons of cheap kerosene, delivering more work per fuel dollar than gasoline competitors. Rumely built oil pull tractors through 1930, continuously refining the design and offering multiple models, ranging from smaller machines suitable for medium farms to enormous tractors capable of pulling dozens of plow bottoms. The total production exceeded tens of thousands of units, making oil pull one of the most successful early tractor designs and establishing Rumely's reputation for innovative engineering and durable construction. The oil pull's legacy extends beyond its production years. The oil cooling concept influenced later engine designs, and the emphasis on durability and maintainability became hallmarks of successful tractor designs. Today, oil pull tractors are highly prized by collectors for their unique engineering, impressive presence, and connection to early tractor history. Restored oil pulls are showpieces at vintage events, and the distinctive oil cooling system and massive proportions make them instantly recognizable, even to casual observers. Number 4. International Harvester Mogul, 8-16. International Harvester's Mogul line represented the company's early commitment to building practical, affordable tractors for ordinary farmers rather than just wealthy operators who could afford massive machines. The Mogul 8-16, introduced around 1914, featured a single-cylinder gasoline engine producing 8 horsepower at the drawbar and 16 horsepower at the belt pulley. This might sound pathetically weak by modern standards, but it represented adequate power for the single-bottom plows and small threshing machines common on early 20th century farms. The single-cylinder engine was simplicity itself: 1 massive piston, 1 connecting rod, 1 crankshaft throw, and a flywheel large enough to store energy between power strokes and smooth the inherently uneven power delivery. The displacement exceeded 300 cubic inches, enormous for a single cylinder but necessary given the low compression ratios and inefficient combustion typical of the era. The engine speed was extremely low, typically around 400 revolutions per minute at working load, creating a slow, methodical exhaust beat and tremendous torque. The cooling system used a radiator and thermosiphon circulation, adequate in most conditions, though marginal during sustained heavy work in hot weather. The Mogul's chassis was basic and utilitarian, a simple frame carrying the engine, transmission, and wheels, with minimal consideration for aesthetics or operator comfort. The operator stood on a small platform behind the engine, exposed to weather engine heat and exhaust fumes, operating controls that required significant physical strength and constant attention. The steering mechanism used a vertical steering column connected through chains to the front wheels, requiring multiple turns, lock to lock, and providing minimal mechanical advantage. The transmission offered 2 forward speeds and reverse, all extremely slow, and requiring the operator to stop and shift lever positions rather than shifting under load. The rear wheels were steel with spade lugs, protruding cleats that dug into soil and provided traction, but made road travel jarring and potentially damaging to road surfaces. The Mogul burned approximately 1 gallon of gasoline per hour at working load, reasonable fuel consumption that compared favorably to horse feed costs when calculating operating economics. International Harvester positioned the Mogul as affordable mechanization for farmers transitioning from horses, pricing it competitively, and supporting it through IH's extensive dealer network. The company sold thousands of Moguls during the late teens and early 20s, helping mechanize American agriculture during a critical period when World War I created labor shortages and food production demands. The Mogul's greatest significance was democratizing tractor ownership. It proved that tractors didn't need to be enormous, expensive machines, affordable only to wealthy farmers, and that smaller, simpler designs could provide real benefits to ordinary operators. Today, surviving Moguls are rare because many were worked until they literally fell apart, then scrapped for valuable metal during wartime collection drives. The few examples that survive are treasured by international harvester collectors and represent important pieces of early tractor history, reminding us that even modest machines mattered when they helped farmers produce food more efficiently. Number 3, Hart-Parr model, 2245. Charles Hart and Charles Parr founded their company in 1897, initially building stationary engines before turning their attention to tractors. The two men met as engineering students at the University of Wisconsin, where they developed both the technical expertise and the partnership that would define their careers. In 1903, they introduced what many historians consider the first successful production tractor, the Hart-Parr model 2245. More importantly, Hart-Parr coined the term tractor, shortening the cumbersome gasoline traction engine that had been used previously. The name indicated the machine's capabilities: 22 horsepower at the drawbar, 45 horsepower at the belt pulley. These ratings reflected actual working power rather than maximum output, establishing a credibility that helped Hart-Parr build customer trust in an era when exaggerated claims were common. The honest rating system contrasted sharply with competitors who advertised peak horsepower rather than sustained working power, creating disappointment and mistrust among farmers who discovered their tractors couldn't maintain advertised performance under load. The engine was a massive 2-cylinder design displacing over 900 cubic inches, horizontal configuration with opposed pistons that created reasonable balance despite only 2 cylinders. The engine speed was extremely low, around 300 revolutions per minute at working load, producing tremendous torque and a distinctive slow exhaust beat that could be heard for miles. The cooling system was innovative. Hart-Parr used oil cooling rather than water, circulating oil through passages in the cylinder head and block, then through a large radiator, where airflow dissipated heat. This system eliminated freezing problems that plagued water-cooled engines in cold climates, though it required careful maintenance to keep the oil clean and the radiator functioning properly. The oil cooling system required approximately 20 gallons of lubricating oil in the system, a substantial quantity that needed regular changing and filtering to prevent contamination from combustion byproducts. The chassis was substantial. The 2245 weighed approximately 14,000 pounds, enormous mass that provided excellent traction and stability, but made transport between farms virtually impossible. These machines were typically sold to one farm and remained there for their entire working lives, often permanently positioned at threshing locations. The massive rear wheels measured over 7 feet in diameter, providing the surface area necessary to distribute the enormous weight and prevent the tractor from sinking into soft soil. The transmission was rudimentary, offering only 1 forward speed and reverse, both extremely slow. The tractor was designed primarily for belt work, powering threshing machines, sawmills, and other stationary equipment, rather than mobile field work, though it could pull plows if necessary. The belt pulley mounted on the side of the tractor could deliver 45 horsepower continuously for hours, making the 2245 ideal for threshing operations where sustained power was critical. The Hart-Parr 2245 represented a transitional design between steam traction engines and modern tractors. It offered internal combustion's advantages over steam, including faster starting, easier operation, and reduced fuel consumption. But it retained the massive proportions and limited mobility that characterize steam engines. Hart-Parr built several hundred 2245s between 1903 and 1907, establishing the company's reputation for durable, reliable machines that could survive decades of hard use. The company continued building increasingly sophisticated tractors through the 1920s, eventually merging with other manufacturers to form Oliver Farm Equipment Company in 1929. The merger combined Hart-Parr's engineering expertise with Oliver Chilled Plow Works, Nichols and Shepard, and American Seeding Machine Company, creating one of the industry's major manufacturers. The Hart-Parr legacy includes pioneering the tractor industry, establishing engineering standards that competitors followed, and proving that internal combustion could replace steam in agricultural applications. Today, surviving Hart-Parr tractors are extremely rare and valuable, representing the earliest days of the tractor industry and connection to the men who literally named these machines and established the industry that would transform agriculture worldwide. The few 22s to 45s that survive are treasured museum pieces and showpieces at major vintage tractor events, where their massive size and primitive engineering remind modern observers of how far tractor technology has evolved in just over a century. Number 2. McCormick Auto Mower. Cyrus McCormick revolutionized agriculture with his mechanical reaper in the mid-19th century, and his company continued innovating into the 20th century with early tractor experiments. The McCormick Auto Mower, demonstrated at the 1900 Paris World's Fair, represented one of the earliest attempts to build a practical, self-propelled agricultural machine. The Automower combined a gasoline engine with a mowing mechanism, creating what was essentially a self-propelled mower that eliminated the need for horses to pull the cutting equipment. The engine was small and primitive by later standards, producing only a few horsepower, but it was sufficient to propel the machine and power the cutting mechanism. The revolutionary feature was the power takeoff concept, using the engine to power implements rather than just providing propulsion. This idea, crude and problematic in the Automower, would become fundamental to tractor design and enable the sophisticated implements that define modern agriculture. The Automower's execution was problematic. It was unreliable, difficult to operate, and expensive compared to horse-drawn alternatives. The controls were complex and non-intuitive. The engine was temperamental and hard to start, and the overall design was too heavy and cumbersome for practical farm use. The weight exceeded 2,000 pounds, far heavier than the horse-drawn mowers it was intended to replace, and the added complexity created maintenance challenges that farmers and rural mechanics weren't equipped to handle. McCormick demonstrated the auto mower at the World's Fair to generate publicity and establish the company's innovative credentials, but they never put it into serious production. The handful of auto mowers built were experimental machines used for demonstrations and testing, rather than actual farm work. Despite its commercial failure, the auto mower's historical significance is enormous. It demonstrated that self-propelled agricultural machines were feasible, that engines could power implements as well as provide propulsion, and that established agricultural equipment manufacturers were investigating mechanization seriously. The Automower influenced later designs by McCormick and other manufacturers, establishing concepts and identifying problems that needed solving before practical tractors could emerge. The engineers who worked on the Automower gained invaluable experience with gasoline engines, power transmission systems, and the unique demands of agricultural applications that would inform later, more successful design. McCormick would eventually merge with other companies to form International Harvester in 1902, and IH would become one of the dominant tractor manufacturers of the 20th century. The path from the crude Automower to IH's sophisticated Farmall and McCormick tractors represents decades of refinement and innovation. But it started with experiments like the Automower that proved concepts and identified challenges. Today, the original Automower survives in the Smithsonian collection, preserved as an important artifact representing early attempts at agricultural mechanization. It reminds us that every successful technology begins with crude experiments that establish feasibility and inspire further development, and that the inventors willing to risk failure and public mockery are the ones who create breakthroughs that change the world. Number 1. Mechwart's tractor. In 1896, When gasoline engines were experimental curiosities and automobiles were barely conceived, Hungarian engineer János Mechwart built what many historians consider the world's first surviving tractor. Mechwart worked at the Ganz factory in Budapest, one of Europe's leading engineering firms, where he had access to advanced machine tools and engineering expertise. His tractor was experimental, built to test concepts rather than for production, but it established principles that would define tractor design for decades. The engine was a primitive internal combustion design, probably using gasoline or a gasoline-kerosene mixture, producing perhaps 5 to 10 horsepower, barely enough to propel the machine and pull light loads. But revolutionary considering the date and the fact that most agricultural power still came from animals or steam. The engine design reflected the experimental nature of internal combustion in the 1890s. Low compression, atmospheric intake valves, primitive carburation, and ignition systems that were barely reliable. But it worked, and more importantly, it proved that internal combustion engines could power agricultural equipment, establishing a concept that would transform farming within 3 decades. The chassis was basic, a simple frame carrying the engine, rudimentary transmission, and wheels. The design showed clear influence from steam traction engines, which were the only mechanical agricultural power most engineers understood. The transmission offered only 1 or 2 speeds, both extremely slow, and the steering was crude, requiring significant physical effort. The tractor was likely extremely difficult to operate, requiring constant attention to engine speed, transmission engagement, and steering, while dealing with unreliable ignition and fuel delivery. Mechwart probably operated the tractor only for demonstrations and testing, rather than sustained field work, because the technology simply wasn't developed enough for reliable daily use. But the demonstrations proved the concept, showed that internal combustion tractors were feasible, and inspired other engineers to develop the technology further. The tractor's survival is remarkable. Most experimental machines from the 1890s were scrapped or abandoned, their historical significance unrecognized until decades later, when they'd already been destroyed. Mechwart's tractor somehow survived, eventually making its way to museum collections, where it's preserved as the world's oldest surviving tractor. The machine represents more than Hungarian engineering or one man's innovation. It represents humanity's first steps toward mechanizing agriculture, toward replacing animal power with engines, toward the green revolution that would feed billions of people through the 20th century. Every tractor built since owes conceptual debt to experiments like Mechwart's. Crude machines that proved concepts and inspired the refinements that created practical, reliable agricultural equipment. Today, Mechwart's tractor stands as a monument to innovation, courage, and the human drive to solve problems through technology. It reminds us that every advancement begins with someone willing to try something new, to risk failure and mockery, to build machines that don't quite work, but prove that someday, with enough refinement, they will. Standing before this century-plus-old machine, you're looking at the beginning of everything, the first chapter in a story that would revolutionize how humanity produces food and reshape civilization itself. These machines weren't just metal and gears. They were leaps of faith, bets on technology that didn't quite work yet, investments in a future that most people couldn't imagine. The engineers who built them, the manufacturers who funded them, and the farmers who bought them were all taking enormous risks, gambling that internal combustion could replace horses and steam, that mechanization could improve farms rather than bankrupting them. Many of those bets failed. Most early tractor companies went bankrupt. Countless experimental designs never made it past prototypes, but enough succeeded to prove the concept, to establish the industry, to create the foundation for the sophisticated equipment that feeds the world today. From Mechwart's crude experiment to the Fordson's mass production, from single-cylinder Moguls to innovative oil pulls, each of these machines contributed something essential to the evolution of agricultural technology. They proved that tractors could work, that farmers would adopt them, that the economics made sense, and that the future of farming was mechanical rather than animal-powered. Which of these pioneers matters most to you? Which one represents the breakthrough that made everything else possible? Drop your answer in the comments, and if you appreciate the stories of innovation that transformed American agriculture and changed how humanity feeds itself, hit subscribe for more deep dives into the machines and the people who built the modern world, one revolutionary idea at a time.